Welcome to the walkthrough for the frequently made mistakes for the master's student version of assignment 1B. First of all, let's take a look at the index of method. Please note you shouldn't say if parameter O equal null, then have some code, and then say if O not equal null. Instead, you want to use else rather than repeating the expression. Let's take a look at another problem with the index of. Note here, there's no reason to have to check whether O equal null in this loop, because of course we already know that it is equal null if we went into this part of the if-else statement. Down here, likewise, there's no reason to check whether m element data sub I is not equal to null. Instead, what you want to do is simply switch the first variable that's used to call equals. Instead of using m element data sub I, which could be null, you want to change that to the parameter O. So you say O dot equals m element data sub I. And so in that particular case, you can get a better check because you don't have to check to see whether m element data sub I is equal to null or not. So it's a bit more efficient. Let's go take a look here at some of the problems with the add-all method. And this is also a problem for the array version of add-all as well. So ensure capacity internal shouldn't be past the current m element data length. Instead, you should be passing the current size plus the size of parameter C to ensure that you have enough capacity to store the entire concatenated combination of the current array plus whatever happens to be coming in collection C. Once that's fixed, then the code down here can be cleaned up quite a bit because there is no longer a need to allocate this new object array, which of course will have been handled by ensure capacity internal. And you also won't have to do two copies. You only have to do one copy of the newly expanded or potentially expanded m element data, which was expanded by ensure capacity internal. And then you'll be going ahead and concatenating the C.to array to that. And also notice in this particular case that you won't need to use C to array in quite the same way we're doing here. You just need to be able to do the copy. Remember, the to array call is going to go ahead and allocate all that memory. And so you don't need to do that. You can come up with clever, more efficient ways of doing this. Down here, this is the remove method. In this case, you don't need to say unsynchronized array.this.range check. You can just say range check. And also, there's no need to go ahead and make this extra copy down here. You can simply use the array copy above. This is making an extra copy for no good reason. You simply have to use the version up here. And then finally, make sure that you assign null to m element data sub m size in order to let the garbage collector do its job properly. Here's the add method. Here's a mistake that was made in add. When you call ensure capacity internal, don't pass in a value of 0. That won't do any good at all. You simply have to take the current value of the size, which is represented with the m size field, and then add 1 to it, and then make sure that ensure capacity internal will auto grow the underlying array of element data to be large enough to hold the new size. In terms of implementation issues in ensure capacity internal, please avoid using magic numbers such as min capacity times 5, especially if there's no comments explaining what you're doing. That's probably a little bit too large, in fact. And also don't do things like this. M element data.length plus 2. What is the 2 for? It doesn't explain. So make sure that you document your code and also make sure you avoid using magic numbers unless you're doing something, for example, like doubling the size, which you could use as a comment and then multiply by 2 or right shift by 1. Let's go ahead and take a look at the for each methods. There was several problems that arose here. First of all, this is too complicated. Use a for each loop. This is not quite the right for each loop here. You need to use a for each loop as was shown in the Java consumer functional interface. So go take a look at that, see how it works. This code is unnecessarily complicated. No need to do it like this. If you use the for each loop properly as shown in the Java consumer functional interface video, you can let the underlying Java type system handle the iterator calls on your behalf. And then down here, just a simple fix. Please make sure that you replace lambda expressions of this form with the corresponding method reference because it's more concise. Now we're into the array iterator implementation. Please Don't use the get method if you check to see if the range is in range by using has next or the various parts therein. The reason you don't want to do that is get will check the range, and we've already checked the range. So either use the underlying M element data sub I indexed by last element index, which is one way to do it if you check the range explicitly as you do here. Or you can use the get method, but do it inside of a try catch block where you'll catch index out of bounds exception and then rethrow no such element exception. So there are a couple different ways to do it, but don't do it this way because it's kind of the worst of both worlds. This code is too complicated. You don't need to have two checks and do two throws of new illegal state exceptions. You can refactor this so it's more efficient. You don't need to check this type of thing twice. Down here in the remove method of array iterator, there's a problem here. M index is being set to the wrong value, or rather you're setting last element index is being set to the wrong value here. You need to reset that. That should actually say last element index. That's being set to the wrong value. Decrementing by 1 is not the right thing to do. And also don't use an exception here. You need to have an if statement using the last element index to indicate whether something is incorrectly handled. Let's now go turn our attention to the array splitterator implementation. So first of all, please make sure you use array as the field type as opposed to unsynchronized array. That's just good Java practice to use the underlying interface rather than using the concrete class. That gives you more flexibility if you need it. We don't really need it here, but it gives you more flexibility. You also don't need to assign current index to 0. You can if you want to, but it's unnecessary because this is also assigned in the constructor. And then down here, if you properly make marray be an array as opposed to an unsynchronized array, there's no need to have to put this cast in. And then finally, this code computed midpoint, but it did it in a way that it was always computing midpoint, and you only have to compute midpoint if it succeeds in passing the if statement. It checks to see whether or not we've got an element, a range that's larger than one element. So this code can be moved inside that else statement, thereby speeding things up in the case where you don't actually go this branch at all. So that's the overview of the frequently made mistakes for the master student version of assignment 1B. Please make sure you fix all these issues. Check your code carefully. I reviewed your code, but sometimes I don't catch every mistake. So the frequently made mistakes video is very important to watch to make sure you understand what's going on.